in the title, 1.8a. I'm splitting this up into 2 days. 1.a altogether is all about inequalities, all the various types. I decided to split them apart, the linears versus the nonlinears, because as you know, linear is easy, nonlinear is not. Why is linear inequalities easy? Why would I make the bold-faced claim that you guys basically, I would bet money, the little money I have, that you guys know the majority of this lesson because of this idea. Solving linear inequalities is 99% the same as solving linear equations. Do you guys know inverse operations? Do you guys know how to distribute and combine like terms? Do you guys know that if you see a +5, you have the -5? All of those knowledge, all of those skills of solving equations apply to inequalities. So you're home free. You're done. What is the other 1%? And I'm not talking about the people with money. The other 1% is this. Whenever you multiply or divide by a negative, or whenever you reciprocate, that's a big fancy word that just simply means yes?
I also cannot see it.
Blue?
Sure. No, like the writing.
Oh, the writing.
Yeah. Yeah. Oh. Well,
You see what you did,
Yeah, you requested a different color. I'll choose a different color. When you
This is now acceptable.
multiply or divide, it looks fine on my screen.
You should have done it a brighter color.
By a
No, like just to mess with them.
negative or whenever you reciprocate. Can I use a yellow highlight? Is that okay?
yeah.
Okay. And that's just so reciprocate means flip the fraction, or just basically means flip, but flip the term. You must reverse the inequality. There you go. So I'm pretty certain that we all have an idea of the first bits. We've done it in Algebra 1 and Algebra 2, but just for completeness sake, let's take a look at some examples. Let's start with the true statement. Certainly this is true. 2 is bigger than -3. That is a true statement. But notice what happens when we multiply by a negative number. Let's say I want to multiply by -4. Right. So on the left-hand side, we get -8. On the right-hand side, we get a +12. And clearly, it is true that -8 is smaller than 12. So we can see here that by multiplying by a negative, naturally, it's not a universal law. It's just what it is. The inequality naturally reverses. Now, this is not a proof by any means. It's only a concrete example, but I hope it convinces you of the rule. What about the reciprocation thing? Let's say we had a true statement like, 2 is smaller than 15 over 2, 15 halves, right? That is certainly a true statement. The number 2 is smaller than 15 halves, which is like 7.5. Well, what happens when I take the reciprocal of both sides? Well, the left-hand side becomes 1/2. The right-hand side becomes 2/15. Notice on the right-hand side, we're dividing by a big number, so now it's a really small number. So certainly it is true that 1/2 is bigger than 2/15. So that's sort of what the rule says, that when you're dealing with an inequality, if if you multiply divide by negative, or you reciprocate both sides, you just have to flip the inequality. Make sense? That's it. That's the other 1%. Congratulations. You know everything you need to know about solving a linear inequality. It's just regular problem solving. Just so I don't leave you empty-handed, no, these are notes after all, let's just do one example for completeness sake. Let's say I ask you to solve, and I'll pick one with fractions because everyone loves fractions. 2/3 minus 1/2 x is greater than or equal to 1/6 plus x. Now, personally, this is Mr. Vo talking. I'm okay with fractions, so I just solve it straight up. Add the 1/2 x over, subtract the 1/6, go home, be happy. But if you are the type of person who fractions are not your favorite thing, then of course the technique is to clear the fraction. To clear the fraction, you find the LCD. Hopefully with regular numbers, my denominators are just 2, 3, and 6. We don't have to do a lot of work mentally. We can just look at it. The LCD should be 6, right? So the LCD should be 6. I forgot to full screen this. So I'm just going to multiply every single term by 6. This guy gets multiplied 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 by 6. Can I use yellow to cancel? Will this bother anyone? Okay, it bothers you? Okay, well, you don't matter. So that's 2 there. 2 and 6 will reduce to 3. 6 and 6 are completely gone, and there's nothing to cancel out in the fourth term. So then you just write down what's left over. 2 times 2 is 4, minus 3 times x is 3x, greater than or equal to 1, plus 6x. Now that is a friendlier looking inequality to solve. And then it's just solving an equation. Just pretend that's an equal sign. Get all the x's on one side, get all the variables, all the non-variables on the other, so on and so forth. Since I personally like to keep my variables positive, I'm going to go ahead and move the x's to the right by adding. And hopefully we can do 2 steps at once. And let's subtract the 1 on both sides. So that gives us 3. These guys are gone. Greater than or equal to, these guys are gone, 9x, and then last step, divide 9. 3 over 9 reduces to 1/3. For all intents and purposes, that's the right answer. And it is mathematically 100% correct. This is where like the vanity of mathematics comes into play. So the next thing I'm about to say is from Mr. Vo. It's not from the great old powerful math, but this is just my thing. That's what it looks ugly. I like my answers with the x's coming first. So I would actually flip everything around to write the x part first. So this looks a lot nicer in my eyes than the top one. But they're both technically the same. Right? And I'll accept either. Now, on the practice, it's going to ask you this, or not ask, it doesn't ask, it tells you. Write your answer in interval notation. Now, we did interval notation all the way back in 1.1. On the low chance that we forgot 1.1, let's do a quick refresher on interval notation. Interval notation is a way to describe chunk of numbers. It's easiest to understand if we can see the interval. So what I'm going to do is I'm going to graph our answer. X is less than or equal to 1/3. So here's 1/3. It's or equals to, so you fill it up. Numbers get less than to the left. I'm not saying you have to draw a number line for every single problem. I'm just saying I'm just doing it for the notes so it's easier to see. Interval notation is just describing chunks of numbers, and it's always from left to right. Start, comma, finish, left to right. Hopefully we can see that this shading at the very left will go on forever. Forever to the left is negative infinity, comma, and you keep shading it until you stop at 1/3. There you go. Interval notation has 2 brackets, a parentheses or a square bracket. Parentheses are for exclusions, or in other words, open circles. And square brackets are inclusions, or in other words, closed circles. So since we had a closed circle on a third, that's a square bracket, and infinities, technically we can never ever reach infinity because it keeps growing. Infinities are always open. This will be the answer that I'm looking for. Right. So just, we have to refresh our memories on interval notation, and that's the answer. Okay? All right. So that's solving linear inequalities. It's just basically solving equations, except you have a handful of extra rules to remember. The rules written in not yellow here. Yep. The other weird thing with inequalities that you really can't do with equations, though, is you can stack them. We call these compound inequalities. Unlike equations, you can actually have multiple inequalities in one problem. It'd be very weird to see an equation with like 2 or 3 equations inside of it, but it's not weird at all to see a problem with 2 inequalities inside of it. There are 2 main compound inequalities. They are the OR inequality and the AND inequality. OR inequalities are very easy to distinguish. They have the word OR in it. For example, 2x minus 5 is greater than 3, or, I don't know, x plus 4 is less than 1. I'm just making it up. That is an example of an OR inequality because it has the word OR in it. Sure, we can't...
Please excuse the interruption. Elias Contreras, please report to Dr. Alvarado's office. Elias Contreras, please report to Dr. Alvarado's office. Thank you.
Sure, we could separate compound inequalities with the word AND as well. So this is a perfectly legitimate example. Say, I don't know, x plus, I suck at making examples, is less than 13, and x minus 4 is greater than negative 8, say. That's a perfectly legitimate AND compound inequality. However, most AND compound inequalities usually have the problems merged together, something like this. Negative 12 less than x plus 2 less than or equal to 18. You're more likely to see the second version of the AND rather than the first version, but both are possibilities. How the heck do we solve them? Well, that's even easier. I don't need you. Go away. To solve compound inequalities that are separated by the physical words or and, just solve the problem separately. That's it. Easiest thing in the world to do. If you have an OR problem or an AND problem that's separated by the word AND, just treat it as 2 separate problems. Don't cross the streams. Don't mix up steps. They're just 2 different things. Right. To solve the other version of the AND problem, I've never researched it. I don't know if it has a specific name, so I'll just use pictures. To solve problems that look like this, I don't know. Right? 3, it's all mushed together. To solve problems that look like that, you just balance all 3 sides. Right. Now, if you're probably wondering, okay, how in the world can a single inequality have 3 sides? Let's just do a quick example here. I did not prepare an OR example because I have faith that you guys know how to solve 2 separate problems at once. So I'm not going to do an example of an OR. I'll just do an example of the AND problems that are mushed together. And for fun, let's pick a fraction one. Actually prepared in advance. Yeah, for once I did an actual teacher thing and came prepared. Negative 1/2 is less than or equal to 4 minus 3x over 5, which is strictly less than 1/4. Again, I'm comfortable enough to deal with fractions, so I would probably deal with the fractions. But if you don't like fractions, use the LCD, which, since all the denominators are in regular numbers, hopefully we don't have to do anything fancy. Use our brains. LCD is 20. Yep. So multiply everything by 20. This is an optional step. If you love fractions or you want to live life on the edge, just go ahead and don't clear the fraction. Just work the problem as is. So on the left here, cancels out to a 10. In the middle, cancels out to a 4. On the right, cancels out to a 5. That is what we're multiplying. Negative 10 times negative 1 is a negative 10. Distribute the 4 in. That's 16 minus 12x. And then 1 times 5 is 5. Right. So this is what I mean by balance all three sides. We have three sides to this problem. The left side, the middle side, and the right side. What will dictate that we have to do? How do I know what inverse operations to use? Just focus on wherever the variable is. So since the variable is in the middle, I'm only going to focus in the middle. That's going to give me the instructions of what to do. Well, I hope it's not like too hard. To solve for x, that tells us we need to get rid of the 16 and we need to get rid of the negative 12. So let's get rid of the 16 via subtraction. And notice how I wrote 16 minus 16 on each piece, the left, the middle, and the right. Do we have a question about how I got something?
We're splitting the 20 too.
Oh, where we got the 20. Okay.
So you just get rid of all this? You just get rid of 16?
I'm just getting rid of it because I'm just solving for this x here. So just it's a regular equation. Get x by itself. Oh, we got to get rid of the 16. That gives us negative 26 less than or equal to negative 12x less than negative 11. And then to get x by itself, we got to get rid of that negative 12. And we get rid of it by dividing. So notice our actions are in blue. Our actions are in blue, and what we've done in blue is divide by negative. So you just have to make sure your symbols flip. So this reduces to 13/6. Flip the inequality, x, flip the inequality. This is a positive 11/12. X by itself? Yes? That is technically the answer. Easy peasy. Now for Mr. Vo's vanity speaking here. When it comes to these and problems, I like less than symbols. I don't like greater than symbols. So what I'm going to do is I'm just going to flip everything. So while this is a perfectly fine answer, this is a better looking answer. 11 over 2 less than x less than or equal.
11 over 2?
Oh, 12. Well, 12. Thank you. 11 over 12. Right. So both of these are fine answers. I like the bottom one because it looks nicer. I always use less than symbols. But the question will say interval notation. So what is the interval notation? First, I'm going to visualize it on a number line. I hope it's not a big stretch of the imagination to see that the special numbers are 11 over 12 and 13 over 6. It's open on 11 over 12, closed on 13 over 6. Right. Feel free to object if you have no idea why. And notice what the inequality says. If you read it separately, this says, and I'm going to read it from the x's perspective. Yes, this does say 11 over 12 is less than x, but from the x's perspective, this says x is bigger than 11 over 12. And then the blue here, from the x's perspective, says x is smaller than 13 over 6. So my shading has to be every single number that's bigger than the left number, yet smaller than the right number. Naturally, visually, that's every single number in between here, which makes interval notation a piece of cake. Interval notation, what number do I start at? 11 over 12, comma, where do we end up? 13 over 6. It is open on the left, closed on the right. That is the solution set. Right. So linear inequalities, skills-wise, it's just regular solving equations, except you have a couple of extra things to keep on your mind, like the reversal of signs. Now the natural question to ask at this point, Mr. Vo, how can you make this even harder? Because this is not challenging enough. And the answer is, well, I can't make this harder. That's it. That's all you have. Simple linear inequalities and compound inequalities. I suppose if you twisted my arm, I could make things harder by tossing some absolute values in there.
What if we don't put the arm?
Well, you should. You should always, demand more from your teachers.
No, it's fine.
Linear No, I insist. I insist to give you these problems. Linear absolute value inequalities. The good news is, here's the good news. Not to say that there was bad news to begin with. The good news is absolute value linear inequalities are 100% the same as compound inequalities. They're just hidden. How do you unhide them? Well, unhide. How do you reveal them? This is how you reveal the compound inequalities. Now, I must warn you, I'm about to use some very high-level math symbols here, so if you don't know something, please ask. But if you have, like, stuff inside an absolute value, and it's less than some number, let's just call it the number c, this is how you reveal the compound inequality. So this will always transform into, you write down the stuff, you trap him in between the less than symbols, and then you squeeze him around the positive and the negative number. That's it. That's how you set up absolute value less than problems. How do you set up if it's a greater than symbol? So if you have absolute value stuff here, and it's greater than some number. Oh, by the way, this guy here, that's an and compound, right? You can probably guess what this next one's going to be. You're right, it's an or. So this way you set up an absolute value is greater than something, you just first write it as is. Nothing changes. Just drop the bars, right? So just write it as is. Or the stuff, what you're going to do is you're going to flip the signs of everything else. Flip the inequality sign and flip the sign of the number. This right here might be a good thing to know. Hint, hint for a note card or something if you were going to write a note card.
We use note cards for the test.
I'll let you use a note card for the test. Yeah.
What's the test?
Next Thursday. Yeah. So that's the moral of the story. Every single absolute value inequality is just a compound inequality in disguise. You just have to write it out first. One caveat, one footnote, one disclaimer, one warning. You do not want to use this transformation until the absolute value is by itself. For example here, say I wanted to do 3 minus absolute value of 2x plus 4 is less than or equal to 1. I'm going to change pen colors and write down the wrong thing. So you don't have to copy this. I'm going to deliberately do it wrong. Kids go, oh, I see an absolute value. I see an less than. So it's going to be this. It's going to be 3 minus 2x plus 4. Wrap it in wrap it in the inequalities and do positive and negative. I see this all the time. This is not true. This does not work. So you do not want to do the rules until the absolute value, until this guy here is by himself. So I hope you guys can see that we need to get rid of the 3, and we need to get rid of the minus first before I do anything. So regular algebra, minus 3 to both sides, negative absolute value, 2x plus 4, less than or equal to negative 2. And then to get rid of that negative, you divide them out. So then you have absolute value of 2x plus 4. Hey, we, personally, our blue math, we divided by negative, so I actually have to flip the symbol. So it wasn't even an and problem to begin with. It was actually an or problem in disguise. So because it's an absolute value that is a greater than symbol, I'm going to be using this idea here to rewrite them. So let's go ahead and do that. So I know that this problem, you just copy it as is, 2x plus 4 greater than or equal to 2, or copy the stuff, I was going to write stuff, 2x plus 4, and then you just flip both symbols. Flip the symbol, and then you got 2 separate problems to solve. Easy peasy. Can I fast forward through this? Can you guys know how to solve simple linear inequalities?
Yeah.
Right. So if you subtract, let's work on the left. If you subtract the 4, you get a negative 2. Divide out the 2, you get a negative 1. Let's work the right inequality. If you subtract the 4, you get a negative 6. Divide out the 2, you get a negative 3. X is less than or equal to negative 3. Now, a lot of students would leave that as their final answer, and technically, I would have to mark you wrong. This is a compound inequality. You need to glue these two answers together with the word or. Okay. Now that, technically, 100% correct. Here comes the vanity part in me. When it comes to or compounds, I always like to write the less than first. I always like to write the smaller number first. So if I was a student and I was submitting this to my teacher, I would write it as, why does it keep moving? X is less than or equal to -3, or X is greater than or equal to -1. It just looks prettier when the less than symbol comes first. But both are technically correct. I'll take either. The instructions on the practice and probably on the test will say write your answers in interval notation. So what is this guy's interval notation? The idea is simple. Or problems, you just graph on the same number line. Right? That's it. So if you ever wanted to visualize the solution to an OR problem, it's just both answers plopped together on the same number line. So if I were to sketch this guy, which you don't have to, but it's sort of nice to do if you are rusty at this. So my special numbers are -3 and -1. It is closed on both. The first inequality here literally says x is less than -3. Numbers get smaller to the left. The second inequality here literally says x is bigger than -1. Numbers get bigger to the right. So in interval notation, hopefully we have two intervals, two chunks of numbers. So let's do the left interval first. The very left number, it keeps going forever to -infinity. And it doesn't stop until we reach -3. Since -3 is closed, I will use a square bracket. In intervals, if you want to glue things together, we need a union, a big U. And then just go ahead and describe this part now. That interval starts at -1, closed, and he goes all the way forever to infinity. This would be the absolute perfect answer I'm looking for. Yeah. So that's everything we need to know about linear inequalities. Solving simple ones is just like solving regular equations, and solving compound ones, you either solve them separately if they're an OR problem, or balance all three sides. I can try to hide the compoundness in absolute values, but once you isolate the absolute values, this is how you transform them into compound inequalities. And that is 1.8a. Yep.